Hello everyone, welcome back to my YouTube channel. This is a part 2 video where we are going to take a look at how to solve problems regarding integers. And if you stumbled across this, I would advise you to take a look at the first part 1 video first to get an understanding of what we are doing here. I will link the video in the description box below, so be sure to check it out. So here we begin. Chapter 1, Integers Problem Solving. Before we go into problem solving, I have a golden rule that I follow every single time, and I would advise you to do the same, so that what we are trying to do is clear and precise. I call this method LVD. LVD. L stands for list out. V stands for visualize, if possible. The second step is optional, visualize. And D is do it. As we go through the questions, you will understand what I'm trying to say here. So let's begin. The temperature of a place at sea level is 10 degrees Celsius. The temperature will drop by 5 degrees Celsius for every kilometer above sea level. As you read along, it's better to underline any keywords that you find important, so that it's easier for you to visualize what's happening. Calculate the temperature of the place at 6 kilometers above sea level. So first, let's list out the information that we have acquired from the question. First is temperature at sea level. It is 10 degrees Celsius. Then we are also given the information that the temperature will drop by 5 degrees Celsius. So when we say drop, it is safe to assume that it is in negative, because it is dropping by 5 minus 5. So for every kilometer, it is dropping, so we can write down as negative 5 degrees Celsius. It is a change. Now calculate the temperature of the place at 6 kilometers above sea level. Alright, we have done the first step of the LVD, which is listing out. The second step is to visualize. I would recommend you to draw it out so that you have a better vision of what's happening. So let me draw it out for you. We're going to have a sea level here. This is the sea level. And at sea level, the temperature is 10 degrees Celsius. And from the information given, we can say that as we go up 1 kilometer, there will be a change of 5 degrees Celsius, where it gets subtracted. So 10 minus 5 becomes 5 degrees Celsius. For this question, you can actually just keep on going one by one till you get to 6 kilometers point. But for the sake of using what we have learned from the first video, I'm going to write out a mathematical equation for it. So as we know, 6 kilometers means go up 6 times. Go up 6 times. So it is safe to assume that we are going to get the mathematical equation of 10 degrees Celsius plus, we're going up 6 times, so 6 multiplied by negative 5 degrees Celsius. You can write down the unit or not, it's not a problem in the working steps, but the answer must always have the unit, so remember that. So we have 10 plus 6 times negative 5. So using BODMAS, we have to solve the multiplication first. So it becomes 10 minus 30 So the answer is negative 20 degrees Celsius. That's it. So I'll go through it one more time. The temperature of a place at sea level is 10 degrees Celsius. So we have 10 degrees Celsius. Then it drops by 5 degrees Celsius, which means -5, -5. We have right here. And since they say it is 6 kilometers above sea level, we have 6. So the first time is -5. Second time it is going to be -10. Third time -15. And at 6 times it's going to be -30, as we have gotten right here. So 10 minus 30, we have -20. If you are still confused about how to do 10 minus 30, as it involves negative numbers, I would highly recommend you to take a look at the previous video so that you have a better understanding on how everything works. So that is the first question. We are on a hot roll. So question number 2. Sheila was at point O at a certain instance. She moved 1.9 meters towards the left and moved 5 steps measuring 0.65 meter each towards the right. Calculate the position of Sheila now from point O. For this question, there is something we have to do. We have to assume that the right hand side is positive, then the left hand side is negative. You can also have it in the opposite way, where right is negative and left is positive. It's just for the sake of calculation, and most often than not we will consider right as positive, left as negative. Same goes for up as positive and down as negative. This is personal preference, but we're going to use that just for the sake of calculation. So listing it out, we're following the LVD method still. So L, list out. First is 1.9 meter. So we're going to write 1.9 meter to the left. That is the first step. And then we have 5 steps measuring 0.65 meter each towards the right. 5 steps measuring 0.65 may seem a bit wordy, so if we can convert it into a single number, it will be much easier. So 5 steps, each 0.65 meter means 1 step is 0.65 meter. So 5 steps will be, this should be simple, 5 times 0.65 which we should get 3.25 meters. Oh, by the way, you are free to use your calculator so that you can do it much faster. And of course, you are allowed to use calculators in your exam, so it's not a problem. So 5 times 0.65, we get 3.25 meters towards the right, to the right. Now that we are done with the first step of listing out the important information, it's time to move on to the second step of visualizing. So to visualize, let's say there is a point O on a number line. There is point O here. Sheila moves 1.9 meters towards the left. So from here we can say 1.9 meters. So she will land at negative 1.9. So the traveling meter is 1.9 meters. She has traveled 1.9 meters of distance. And now from there she moves 0.65 meter each, which is 5 steps, and we have calculated that to be 3.25 meters to the right. So now here you might get confused that and you write 3.25 right here. But is that correct? No, it is not. This is where you can get a bit tricky. 3.25, they're referring to the distance traveled by her from this position of -1.9. So from here she moves 3.25 meters. So for those who have not watched my previous video, I would highly recommend you to watch it now, pausing this video, because what I'm going to say next is going to be heavily related to that. Alright, I hope you have watched it. Do you remember from in the previous video I talked something about position and action? So as you see, -1.9 is the position. Then adding 3.25, which is moving 3.25 meters to the right, is the action. So what happens here is we get the mathematical equation of -1.9 plus, which is the -1.9, which is the position, plus 3.25 meters, which is the action of moving towards the right. So 3.25 minus 1.9, we get an answer of 1.3 meter, which is a positive number. And it's safe to say that Sheila is standing at the position 1.3 meters to the right. So the answer would be Sheila is 1.3 meters to the right. Now that second question is done, let's move on to the third question. The third question is quite tricky, to say the least, but let's keep to the method that I've taught you, which is LVD, so that we are able to get the most precise answer without much difficulty. So here we begin. Jasmine moves 9.5 meters towards east, and she moves 10.7 meters towards west, and then 6.8 meters towards east. Describe the movement of Jasmine so that she can go back to her original position. So before we go into this, it is important that you know which direction north, south, east and west actually is. So here we are only talking about east and west. There is no mention of north and south, so we are safe. You just have to know what is east and what is west. So for those who are wondering where they are, let me draw the cardinal direction for you. The top, the one pointing upwards, will be north, downwards is south, this one will be west, and this will be east. The left is west, right is east. Now let's list out according to the LVD mnemonic. So 9.5 meters towards east, that is the first step. Second step will be 10.7 meters to west. Second step. Then the third step and the final step is 6.8 meters to east. This is the third step. So describe the movement of Jasmine so that she can go back to original position. So before we see that, we have to know where she is standing right now. So moving on to the second step, visualizing. So let's take what I've drawn here. Let's take what I've drawn here as an example. So let's assume that Jasmine is standing here. She moves towards east, west, and east starting from this position. So as I said in the earlier question, you have to assume one of the side as positive or negative. So for the basis of continuation, we will say moving towards the right, which is the east, as positive, and moving to the left, which is west, as negative. So from here we can say Jasmine moves towards the east 9.5 meters, then she moves towards the west 10.7 meters and move towards east 6.8 meters again. So for this question, you don't really have to visualize much. You can just write a mathematical equation based on the direction and the negative positive symbol. Of course, since she's moving, you're going to add everything. The only thing that you're going to change is whether it's negative or positive. So starting from the initial position, Jasmine moves towards east for 9.5 meters. So east will be positive. So we just write down 9.5 positive. This is a positive number, and then plus 10.7 meters towards west. West is negative, so let's add negative 10.7, and we're going to add 6.8 meters, which is east, so it's going to be positive, so 6.8. And what are we going to get? I'll give you a moment to use calculator. And we have the answer of at 5.6 meters to the east. Now we have gotten where Jasmine is standing at the moment, but that is not the question. The question is describe movement of Jasmine so that she can go back to original position. So now from her initial position, Jasmine is standing 5.6 meters towards the east. So to go back to her initial position, she has to walk 5.6 meters towards west. Towards west. As simple as that. So the answer will be Jasmine must walk 5.6 meters towards east. That's all, and that's it. So question 3 is done. Now let's move on to the second last question, question number 4. This question is also quite tricky, but I'm pretty sure you can handle this. A lift was at level H. A lift was at level H at a certain instance. The lift went up 2 floors for a height of 10.2 meters. The lift went down 5 floors. Calculate the distance of the lift from level H now. So from what we have seen in the previous questions, it was always the horizontal difference, whether it's east or west. It has always been left or right, so it's always been horizontal. Now we are taking a look at vertical. So vertical, the concept is still the same. Up is positive and down is negative. For the sake of continuation and for the sake of understanding, let's just keep it this way. Up is positive, down is negative, right is positive, and left is negative. So first we have to follow the LVD listing out. So to list out level H at a certain instance. So for this question, level H will be the sea level per se. For example, from past video, as I said, sea level will mark the position 0. Anything that goes up will be positive, then anything that goes down will be negative. That is, level H will be our initial position for this question. And the lift went up 2 floors for a height of 10.2 meters. This is basic arithmetics. 2 floors, 10.2 meters, which means 1 floor we have to divide it by 2 to get the answer. So let's get the answer. We are getting important information from the question. So two floors, we see 10.2 meters. And then for a single floor, what we have to do is here divided by 2. So here the same, divided by 2. We get 5.1 meters. And then the lift went down 5 floors. So here is where what we have figured out from the first part of the information will help us. 2 floors is 10.2 meters. 1 floor is 5.1 meter. So how much is 5 floors? So we are just going to have 5 times 5.1, which we get 25.5 meters. This is the distance the lift went downwards. So now we have to calculate the distance of the lift from level H now. So level H, as I said, is the similar to sea level from the concept earlier. So as I said, anything that goes up is positive and anything that comes down is negative. So here we can just write down went up 2 floors as positive, which is 10.2 plus 10.2 or just 10.2 is the same thing. So I write 10.2, write 10.2 meters. Then we have went down by 5 floors. We are still going to add because it's moving, but since it went downwards, we are going to put it as negative. So negative 25.5 meters. So the answer, if you follow the number line method or the sea level method or the debt and repayment method, whatever the method is, as long as the answer is correct, we are cool. So the answer would be negative 1.5, which is 15.7 meters. Do you see that? I'll give you a moment to just take it in. So 10.2 meters plus minus 25.5 meter. So from the previous video, we know that when plus and minus comes together, it's going to be minus because not same sides. So it's just essentially 10.2 minus 25.5, which we get negative 15.5 meter. But is the question over? Is this the answer? Now this is where you have to be very, very careful. This is the position of the lift. It is 15.5 meters downwards from level H. But the question is not asking for the position. Rather, they are asking for the distance of the lift from level H. The distance, when it comes to distance, we will not have any signs in front. Negative, positive, no signs. It just has to be the value itself. So the answer essentially would be 15.5 meters. That's all. you have to take care of these little nuances that comes here and there that determines what the answer to the question is. So when doing mathematical questions, make sure you pay attention to each and every single aspect of the question so that we don't go over or less. If you notice carefully, I skipped the visualization method for this. As I told you earlier, visualization is an optional method. If the question is way too easy, or you can visualize in your mind very clearly, there is no need to waste your time doing visualization. Visualization always helps when you are attempting a very, very difficult question, and I promise you, you will face those kinds of questions very soon. Not scaring you, but it is part of learning. So when you are attempting that kind of questions, make sure to use visualization, as it will help you a ton. Okay, now we have done the first 4 questions. Now we are going to the last question. This question is pretty easy. I would not say this is very difficult. So I will give you a few seconds to try it. So you can feel free to pause the video right now and try it yourself. Then I will tell you how it works in 5 seconds. 5, 4, 3, 2, 1. So now I hope you have done the question. So let's see. A treasure chest hidden in the year 56 BC was found in the year 300 AD. For how many years was the treasure chest hidden? So pay close attention. How many years? They're asking for the value, not the position, not negative, not positive. It's just how many years, the duration. So still the same method, LVD. L stands for listing out. So the chest started to be hidden in the year 56 BC. So what is BC, you may ask? BC means before Christ. Before Jesus Christ was born. 56 years before Jesus Christ was born. Then what is AD, you may ask? AD stands for Anno Domini. I'm pretty sure I pronounced it wrong, but what it means is it's in the year of Jesus Christ. So the year Jesus Christ was born, starting from that year, we will call everything, the years that comes afterward will be called AD. So here 300 AD means 300 years after Jesus Christ was born. So if you look at it carefully, you can also see a number line pattern here, where the year Jesus Christ was born marks the 0th position in the number line, and anything that's before, which is BC, before Christ, is denoted by symbol negative, and anything that is after 0 is AD, which is denoted by the positive numbers. So let's see. 56 BC is the first information. 56 BC. And then 380 is the second information. So for this question, there isn't much of a visualization, because from the number line itself, you can already see how it looks per se. Now we are going to see the duration. So if it's a normal duration, for example, I'm giving an example. 2016, there was a robbery. Then 2018, the robber was caught. So how many years did the search for the robber went on? What will you do? You just take 2018 minus 2016. As simple as that. you take the larger number and then you subtract it by the smaller number. We're going to do the exact same thing here. So larger number here will be 300 AD because it is after Christ, and then 56 BC will be the smaller number, which because it is before Christ. So from here it is this 56 BC will be smaller and 300 AD will be larger. So what we're going to do now is we are going to write 300. Since it's AD, it will stay as positive, but we are going to minus 56 BC. Since BC is negative, we are going to write negative 56. So here negative negative are same sign, so we are going to make it into positive. As I said in the earlier video, same signs will become positive, different signs will become negative. So we have 300 minus 56, which essentially becomes 300 plus 56. So 300 plus 56, we get 3, 5, 6 years. So there you go. The treasure chest was hidden for 356 years. That's all. I hope that you got the correct answer as well. If not, don't worry. You can always practice more and then improve. So I recommend you to do as much exercises as possible, and also try to attempt the questions in the textbook. I'm telling you, the textbook has some of the best questions that you can ever see. So make full use of the textbook while you have it. Alright, I hope that you understood what I've explained today. If you did not understand any questions, feel free to leave your question in the comment sections below. And also, you can send any questions to my email. I will put it down in the description box below so that I can answer you back. I'll try my best to answer every single comments and also every single email that I receive. So hope you have a good one, and till the next video, signing off, it's Rishi. Bye bye.